Florida. It's an angler's paradise.
Florida likes to think that we are the sport fish capital of the world.
The value of recreational fisheries in Florida overall is around $12 billion per year.
Tarpon and snook are two of the prized game fish the Sunshine State is famous for.
There's a couple reasons that tarpon are so enticing. One is their massive size. They can grow upwards to 250 pounds, almost over 7 feet long.
It's a fish that migrates great distances. They live for a really long time.
He's big, he jumps. It's kind of like almost the perfect fish.
The adrenaline rush of it just really makes it super exciting and a lot of fun.
The great thing about snook is that they're ambush predators. So no matter what you're using to fish, you're gonna see a show.
You got him, yes.
It's so much fun to catch a snook. You'll see the bite, and then they'll be airborne, just like a tarpon.
Without them, Florida wouldn't be the same.
When they're young, both tarpon and snook rely on murky, mangrove-lined tidal creeks and backcountry ponds.
I would call them essential fish habitat.
Clearly, as more and more people come here and it gets more and more developed, these kind of areas are going away.
Mangrove forests are inhospitable to humans, and with nearly 1,000 people moving to Florida every day, many have given way to coastal development.
The biggest threats to coastal fisheries are habitat loss and degradation.
Even with snook and tarpon being mostly catch and release, we're still seeing declines. What that tells us is it's much more than people fishing.
Habitat is absolutely crucial.
How do scientists study the environment juvenile snook and tarpon need to thrive? And can habitat restoration help ensure the future of the fisheries?
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources. Additional funding was provided in loving memory of David G. Perot by the Perot Family Endowment for Environmental Education.
In Charlotte Harbor, on Florida's southwest coast, tarpon is king.
Charlotte Harbor is home to Boca Grande, which is the world-renowned tarpon capital of the world.
We have so many fish. In 2010, there was an economic study that found that just locals fishing for tarpon, so not including the guides or people coming in from other states, equated to $110 million annually that was put right into this community.
And it's not just Boca Grande Pass that attracts anglers to this area. Miles of shallow mangrove creeks and flats are a favorite with fishermen as well.
It's just a phenomenal place. If you close your eyes for 30 seconds, you could be completely lost if you don't know where you're going. And that to me is what I really love, is getting in the backcountry like this and just being in that raw Florida.
Slow it down, distribute fast, 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 fast. You got him, yes, that's a snook.
Since 1989, biologists with the Florida Fish and Wildlife Conservation Commission, or FWC Charlotte Harbor Lab, have tracked the abundance of recreational sport fishes and their prey. This fisheries independent monitoring program consists of year-round monthly sampling in Charlotte Harbor.
We are a long-term monitoring program. Our sampling protocols stay the same so that we can track trends in populations over time. In Charlotte Harbor, every month we're pulling roughly 120 nets.
Since 2015, The scientists are also setting seine nets in tidal creeks that are important nurseries for juvenile snook and tarpon.
We set the seine net in a semicircle along the shoreline with one person at one end and then the other person at the other end. They will walk along the shore until they meet, and then they will pull that net in, and we will see what we've caught. A dozen?
Or more.
Or more tarpon?
All young of the year tarpon. We have a snook here. This fish is probably about a year old. We will measure in standard length, which is to the end of the vertical column right here. So this fish is 306 millimeter standard length. Fork length is 352, and the total length is 387.
We will identify all of the sport fish and select invertebrates, and then we will measure most of them and we release them. Our sites are randomly selected. We're not going out to spots where fishermen know that there's snook or know that there's no snook. We are trying to cover the entire estuary. And then we're stratifying by habitat type to make sure that we're sampling in a variety of habitats that these sport fish are using.
This includes remote mangrove-lined ponds, which are difficult to reach.
We'll get measurements on all these.
We caught 11 tarpon and 6 mine cichlids. All the tarpon that we caught were all young of the year fish.
What we'll do at each site is we'll record the type of mangrove and how inundated those mangroves are at the time of sampling.
The juvenile fish find their way into these backcountry waters in the summertime, after the adult tarpon spawn offshore and the adult snook spawn along beaches and the inlets to the estuaries.
That's when we have our rainy season, and that's when we have our highest tides. So the larvae will ride those tides up into the tidal creeks, and then they will swim to the headwaters of the tidal creeks, and they will swim around the mangrove roots to get into these back ponds, pretty much as far back into the landscape as they can go. There's a vast mangrove forest that separates these ponds from the creek, so there's just a small amount of water that connects these coastal ponds to the tidal creeks. They're looking for shallow habitat with protection from predators and an abundance of prey fish. They also, when they're juveniles, can tolerate low oxygen water.
Some of these remote ponds are completely cut off from the estuary during the dry season, giving the juvenile fish a chance to outgrow predators that await them once access to the creeks is restored. Another group studying tarpon and snook in the backcountry is the Bonefish and Tarpon Trust.
It's estimated that we've lost about 50% of our mangrove habitat in Florida. So when you put it in terms of juvenile habitat, you've lost about 50% of your juvenile habitat.
To the extent that overall population of tarpon and snook is dependent on the amount of juvenile habitat, we'll never, ever have as big a population of those species as occurred, say, 100 years ago. We've been spending decades managing the fishermen, and we've been losing habitat, and that's why the fisheries are declining.
You could take every human out of here, take every boat out of here. If you lost the habitat, you've lost the fishery.
One of the things that a lot of people don't understand about fisheries management is that it's entirely about how many fish are harvested, what their growth rates might be, how many are left in the water. There's a real recognition of the need for habitat management as part of fisheries management. It just hasn't been implemented. And we're at the point where if we don't implement it, the game's over.
There are many steps that would need to be taken to make the leap to ecosystem-based management. and we're currently at the beginning phases of that. We are collecting the fish data.
Got a snook at 67.
We're also collecting data on the types of habitats that they are using.
Bottom type is mud.
We are relaying that information to the fisheries managers.
We think that working with FWC on snook and tarpon, because we know a lot about their habitat use, will teach us how to do that. So as new development happens or as different zoning happens, it can incorporate the importance of the fisheries.
In the meantime, the scientists are focusing on restoring impaired habitats. One such project focuses on an area known as Coral Creek on the Cape Hayes Peninsula, just south of the community of Rotunda.
This particular location was developed as residential community with saltwater access, which is why the footprint looks like a canal system that you would see in any other coastal community. The development project started in the 1960s and ran out of funding, so the canals were left abandoned. Currently, the state of Florida owns the land, and it's managed by our Florida Department of Environmental Protection, or DEP.
The initial restoration plan was to fill in the canals and return the topography to pine flatwoods. But then, a group of state employees discovered tarpon rolling in one of the abandoned canals. Knowing this, the Southwest Florida Water Management District, which is the agency tasked with carrying out the restoration, encouraged the biologists to come up with a new restoration design that would be beneficial for the fish.
We brought the biologists together with the engineers. Everybody realized that this was a really unique opportunity. We could set the different canals into an experimental design to test what characteristics of the habitats were better for juvenile snook and juvenile tarpon.
Because we had 6 different canals to work with, we decided to go with 3 different design treatments and duplicate each of those. So 2 of the 3 designs have what we are referring to as a sill mouth. This means that the mouths of the canal are built up higher than the elevation of the rest of the canal so that water is only flowing through during higher tide events or during storm surge events. What this does is prevents larger predators coming into these nursery habitats when the juveniles are coming in as larvae.
We also wanted to look at depth of the water body. Snook and tarpon tend to utilize slightly different sections of the ponds. The tarpon tend to hang out in the deeper holes, and the snook tend to hang out more at the edges of the marsh.
So in one of the sill mouth treatments, we included a deep hole right after the sill with a shallow meandering creek behind it. Now the reason that we have the deep hole is because tarpon, as the water gets colder on the surface, they can find warmer water down at the bottom of the hole, and vice versa, as it gets hot in the summer, they can cool off in the deep hole. To test that deep hole theory, we created the second treatment to have the sill mouth, but without the deep hole. So it's shallow throughout with the meandering creek system on the tail end. The third and final treatment lacks that sill mouth, so the water is open and flowing year-round. It also does have that deep hole, again with the meandering creek system.
To see how well the restoration is working, the Bonefish and Tarpon Trust scientists capture and tag tarpon and snook in all of the canals each month.
Each snook and tarpon that we capture, we scan to see if it previously has a tag implanted. This one doesn't, so we then measure the standard length, 251, which is to the end of the vertebral column. Then we measure fork length. This guy is 280 millimeters. Since this guy doesn't have a tag, we'll go ahead and put one in. First, we pull a couple scales, make an incision, pop the tag right into the abdominal cavity, and then let him go.
These pit tags work just like the microchips used in pets. Each tag has a unique ID number, which the scientists record. By tagging the fish over a period of 2 years, the experts can determine how many tarpon and snook are present, if they survive, and how much they grow.
So if we recapture a fish, we're able to see how much it's grown from the time that we tagged it to the time to recapture. Growth is arguably one of the most important characteristics for a juvenile fish. As they get bigger, the more things they have available to eat and the fewer things are able to eat them.
Past research has shown fish grow faster when they have access to a diverse diet.
We do lavage, or as we like to call it in the field, puke them, pump their stomachs. We can look at what they're eating, compare it to what's in the creeks, and see if they have a particular preference. Because what we've found in the past is that altered habitats have fewer prey available, and the snook in the natural habitats are eating twice as diverse a diet. So right here we have a sailfin molly, but there are also some larger scales here. We take all this back to the lab. We can look at the scales and figure out what type of fish it came from, and we could use that to recreate the diet.
The scientists also use the pit tags to track the movements of the fish. Inside the entrance of each canal is an underwater antenna array that can detect the implanted pit tags and identify fish as they swim by.
Think of it as an automatic toll booth system.
These antenna arrays, they track the fish's movement in one canal, out the other canal. We'll be able to see if it's more productive for them to be secluded or if they need that ability to swim in and out through the open mouths of the canals. We also have an antenna array system that connects to the open estuary, which gives us the final tally on immigration.
While the Bonefish and Tarpon Trust science team is targeting juvenile snook and tarpon in these restored canals, the FWC biologists count and measure all the fish found at the site.
So we caught a couple different species of Mahara. We had some striped Mahara, some Irish Pompano. We caught a Gulf killifish, Gambusia holbrooki. These are all important forage fish for juvenile snook and tarpon.
And we also got a juvenile snook in here as well. He is a new recruit. It's a young of the year juvenile snook.
Prior to the restoration, the Bonefish and Tarpon Trust scientists conducted fish sampling for 16 months at each of the canals.
That way we can compare before and after restoration to see which specific treatments are more successful for nursery habitat.
It's too soon to say if the restoration is successful, but the biologists are already seeing encouraging signs.
From the beginning, juvenile snook and tarpon have recruited to these habitats, and there is an incredible amount of prey fish for them there. We're seeing all of the same forage fish in the restored ponds as we're seeing in the natural habitat.
We're catching a lot more juvenile snook and tarpon than we were before the restoration. So that suggests it's successful. But it's not about the number of juvenile tarpon and snook you see in those creeks. It's how many survive to leave for the next life stage. So if we see a lot of those fish going past the antenna and leaving those backcountry spots to join the adult population, then that's a success. And that'll take a couple of years to figure out.
Tarpon and snook also occur on Florida's east coast, where the juveniles encounter a unique set of challenges.
There's very, very little left of a natural ecosystem in the Indian River Lagoon. Compare this to Southwest Florida, where a lot of the habitat is still relatively natural.
The Indian River Lagoon, most of its mangroves, something like 85%, are in impoundments.
This entire area before the 1950s was known as mosquito country. It was actually unlivable for most people. Before the impoundments that were here, the salt marsh mosquitoes made life very challenging. They would come up in literally the billions.
Starting in the 1950s, berms were built around the salt marshes and mangroves in this part of the state to help control rampant mosquito populations and make the region more habitable for humans.
They have these circular impoundments. When the water levels start going down, they fill them up with water. The salt marsh mosquito needs exposed mud to lay their eggs and to reproduce. And by having water in these impounded areas year-round, it essentially interrupts the life cycle of the salt marsh mosquito.
And it did a really good job of inhibiting mosquitoes from breeding. There are well over 100 mosquito control impoundments on the Indian River Lagoon.
By the 1980s, several scientists and managers realized the impoundments were nurseries for much more than mosquitoes.
There are nurseries for tarpon, for snook, for all different kinds of fish species, and isolating all of these nurseries was not good for the fish populations.
So they came up with a project of putting culverts in and connecting these impoundments back to the lagoon system.
This made it possible for fish to move back and forth in the wintertime when water levels are high.
Then in the summertime, they'd close off the gates, pump the impoundment full of water, and now they could control mosquitoes. And they just assumed that as long as they had the impoundments open for much of the year, they served perfectly good nursery function. Well, about 5 years ago, we decided to really test that and see when and how do juvenile fish leave these impoundments and go back and join a regular population.
To do so, the scientists teamed up with the Indian River Land Trust, which owns many of the mangrove shorelines where mosquito impoundments can be found.
To date, the Land Trust has protected 1,200 acres and 12 miles of lagoon shoreline. Probably about 700 or 800 acres is in mosquito control impoundments, and each impoundment is managed by the Indian River Mosquito Control District. They're a great partner because they understand that science should always be looked at so that we can try to manage these impoundments the best way we can for the fish and wildlife habitat.
Past research in unaltered mangrove creeks showed that snook tended to leave their juvenile habitat after a year.
Which is the next summer after those larvae came into the creeks. They didn't leave the creeks during the winter. So that means that the impoundments are disconnected from the estuary when the juveniles need to come and go.
Knowing this, the scientists set up an experiment at the Indian River Land Trust's Bee Gum Point Preserve.
The basic idea was to let's catch juvenile fish, let's put little tags in them, and let's track their movement in and out of these impoundments. And much to our surprise, even though we tagged hundreds and hundreds of juvenile fish, very few of these fish left the impoundments during the fall, winter, early spring when the impoundments were open. But shortly after they closed off the impoundments, pumped them full of water, now we're getting all kinds of detections on our antennas on the inside of the culvert saying, hey, I'm looking for a way out of here. And they couldn't get out, they were stuck. So we were perplexed at first what to do. And we talked to mosquito control and they agreed to open up the impoundment, open up the gates, allow water to go flooding through for a week, and then they'd close the gates off again, pump it full of water and go back to controlling mosquitoes. And it was amazing. Within the first 24 hours of opening these floodgates, we had massive numbers of juvenile snook, juvenile tarpon, all flooding out of the impoundment. Once the juveniles reach a certain size after about a year, they can no longer grow well in this mosquito control impoundment. So it's time to move on.
Given the success of the experiment, the research is now being expanded to other areas.
We're repeating it in Bee Gum. We're going to do it in 2 other mosquito control impoundments here in Indian River County. And if it's effective in all 3 impoundments, now we've got something we can go to the managers and say, hey, look, this is really worth adding to your management strategy playbook.
And the Mosquito Control District is willing to work with the Land Trust to open these culverts periodically in the summer to allow for the fish immigration.
The Sunshine State's unique coastal ecosystems and the fishing opportunities they provide are unrivaled in the continental United States.
One of the things that brings a huge number of people to Florida is the quality of life.
Certainly you come to Florida for the weather and for the water.
But as more and more people head south to experience the Florida lifestyle, many of the natural qualities that attracted them in the first place are in decline.
That lifestyle is entirely dependent on a functioning ecosystem. So as those habitats are degraded, our quality of life declines as well.
We want to be able to protect it and keep it going for generations.
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources. Additional funding was provided in loving memory of David G. Perot by the Perot Family Endowment for Environmental Education.